Hello everyone, and welcome to this video. Further discussing statistical process control. This time we're getting more into control charts and one specific type of control chart called the R chart or range chart. And this is a chart that's used to monitor the variation of a process over time and determine whether or not that process is in statistical control or not, in terms of its variation. Alright, so I'm going to start off here with some pages that I had in my last video. The last video I had was on, it was an introduction, statistical process control, and an introduction to run charts and control charts. At the very end of that video, had these same pages up on, talking about control charts. So I want to just go over those briefly with you again. So, what is a control chart? It's like a run chart. You're monitoring some data over time, but you're not monitoring every individual piece of data. What you're doing is you're taking groups of data and then just taking one characteristic from those groups and monitoring the characteristic over time. So you're not monitoring every single individual piece of data, but just some aspect, some characteristic of groups of data as time goes on. So a control chart, or sometimes referred to as a Shewhart chart, named after Walter Shewhart, who first introduced these back in 1924. A control chart of a process characteristic, maybe the mean of the process, the variation of the process, as we're going to see today with the R chart, or other things, right? Not just the mean or variation, but other characteristics could be monitored. Consists of values plotted sequentially over time. So it's like your run chart. You have two axes, vertical, horizontal axis. The horizontal axis is typically representative of time, the time passing in days, months, years, seconds, minutes, whatever. Right? And the vertical axis is your characteristic values, that characteristic that you're monitoring, whether it be the mean of sample 1, then the mean of sample 2, the mean of sample 3, the mean of sample 4, the mean of sample 5, etc. Today, though, for R chart, when we talk about the R chart or a range chart to monitor variation, we're going to be taking and finding the sample ranges, right? Which is I take a sample and take the largest value of that sample minus the smallest value of that sample. So it's like, for all these dots here in my chart, that'd be like, the range of sample 1, the range of the next day's sample, the range of the next minute's sample, whatever, the next sample in time as time goes on. So range for sample 1, range for sample 2, range for sample 3, range for sample 4, etc. Right. So like I said earlier, you're not putting a data value. You're not monitoring every single individual piece of data, but just the ranges of the samples of data, or the means, or the proportions, or the standard deviations, or what have you. So again, it looks like an R chart. It looks like a run chart, right? You have all these ranges, all these means, all these standard deviations marked down, whatever you have. They're connected by some segments. But in addition to these data points, these ranges or means or whatever, you have these three lines that appear that are going to be typically written on a control chart or Shewhart chart. One is the center line. The center line will be located at the mean value of all the characteristic data that you're recording. So the mean value of all the ranges, or the mean value of all the means, the mean value of all the standard deviations, whatever. Right. Then you're going to have another one that's an upper control limit, or UCL. And a lower control limit line, or LCL. And these are placed on the chart to monitor, and determine when is a particular data value significantly high or significantly low, or exceptionally high, exceptionally low. If you recall the last video on run charts, we looked at a run chart and would consider one of the criteria that would make us determine that a process wasn't in statistical control was if there were data values that were exceptionally high or exceptionally low. Well, now we're going to have these lines, these upper control limits and lower control limits, to help us determine that more specifically. So if any particular data point shows up above the upper control limit, we'll consider that point exceptionally high, and then the process out of statistical control. And if any data point shows up, below the lower control limit, or the LCL, again we'll consider that point exceptionally or significantly low, and then consider that process, to be out of statistical control. And then, as with the last video, I had some examples of control charts you might come across in your study of statistical process control. One is, one for monitoring variation. Now there are actually a couple of these, more than just the R chart. There's also the S chart, which would be for standard deviations, and maybe I'll write that as well here for monitoring variation. Maybe also the S chart. Remember, S was the symbol for sample standard deviations. I'll tell you right now that the R chart will be used when the sample sizes are small, and an S chart would be recommended when sample sizes are larger. So I'll point that out as well. Right, so R chart used when samples are small. Now what they mean by small depends on what author you're talking about. In the text I'm looking at, that I'm basing this video on, a small sample would be less than or equal to 10. Alright, so when my samples are less than or equal to 10, the size of 10, we'll monitor variation with a R chart or a range chart. But for samples, if my samples are larger than 10, then I would perhaps more likely recommend monitoring the variation of the process with an S chart, or standard deviation chart. But this video is particularly on R chart, right? And I'm not even going to do a video on S chart. Right? Just these three charts. And again, there are other charts, S chart and others, but my videos on process control will be simply covering these three. So another one is for monitoring the means of a process, the sample means. Remember, sample mean was usually represented by X bar, right? So it's an X bar chart. Another for monitoring certain attributes, right? And this is a P chart, or a proportion chart, right? P was for a sample proportion. Well, actually P hat, I guess you should call it a proportion chart. So you're monitoring, hey, in this sample, what proportion of the data is in this category or that category, or has this attribute or that attribute. All right, again, we'll have a whole separate video on P charts coming up. All right, and then the whole point of making these charts is to interpret them, right? We have to decide whether or not the process being studied, the process being monitored, is within statistical control or not, or statistically stable or not. And I went over some criteria in the last video as well, right? There was But those criteria can be summed up with these three rules here that we're going to follow. And there could be more, if, depending on what company or what author is discussing their control charts. But how do I interpret a control chart? So we're going to say that a process is not statistically stable or not in statistical control if one or more of the following out of control criteria are satisfied. So if there's an obvious pattern or trend or cycle in the data, then that doesn't occur naturally. It doesn't. We're going to say that the process is not in control, not stable. And this number one here sums up a lot of stuff I was brought up in the runs chart video. If there's an obvious upward trend, obvious downward trend, a major upward shift or a major downward shift in the graph, in the chart. Again, if there's an obvious pattern, the data are forming almost a perfect straight line, or a perfect wave form, or a perfect parabola. They're close to forming some obvious pattern. That's not going to happen naturally. So there's probably something in the system, something in the process that is awry, causing it to form some obvious pattern. Then we would have to go back in and say, hey, that's not stable. Go back in and figure out where we can, fix the process. This was number 2, was about those exceptionally high or exceptionally low values I mentioned, right? If at least 1 point is above the upper control limit, or at least 1 point is below the lower control limit, then we'll consider a process out of control, not stable. And then this is one that, the run of, number 3, the run of 8 rule. I've seen some books where it's run of 7, but the text I'm pulling this out of is just, using the run of 8 rule. If there are at least 8 consecutive points all above the center line, or at least 8 consecutive points all below the center line, then we'll say the process is not stable, not in control. Reason for that is, you think of the center line, right, the mean value. If you say, hey, if you kind of figure like it's a coin flip, say the probability of being above the center line and being below the center line, you think of those as about the same, about 50-50. Then the probability of having 8 points in a row above the center line, or 8 points in a row below the center line, that would be like the probability of flipping a coin and getting 8 heads in a row, right, or 8 tails in a row. The chances of that happening are incredibly slim, right? It probably wouldn't occur if the process had a natural variation to it, if the process were stable. So if you see at any time there are at least 8 points in a row above the center line, or 8 points in a row below the center line, then we'll determine that the process is not in control, not stable. All right, as I mentioned, a little note here: some companies, some manufacturers, whoever's monitoring a certain process, some authors use additional criteria, besides these. But again, like I said, number 1 there sums up a lot of them. So yeah, if you see any obvious patterns, exceptionally high or low points, or these runs of 8 or more above or below the center line, then we're going to say the process is not stable. You're going to have to go in and figure out why isn't it stable, what do I need to fix to get stability back. Alright, so now these next couple pages are specifically on the R chart, right, or the range chart, which is a control chart for monitoring the variation in a process, the spread. So a control chart for monitoring variation, the R chart. Alright, an R chart, or range chart, is a plot of the sample ranges used to monitor the variation in a process. Right? Again, a plot of the sample ranges over time. Right? So what's sample 1's range, sample 2, sample 3, as time goes by. Used to monitor the variation in a process. And if you recall again from last video on run charts, if the variation in a run chart tended to get larger, right? So maybe all the points started off not that far apart, and then the variation got larger and larger. The data started to spread out more and more as time went on. That was bad. Right? We don't want that to happen. The larger the variation, the worse off, right? That means your machines or whatever you're manufacturing or whatever service you're providing is getting worse and worse, and it needs to be fixed. And I pointed this out earlier as well. A little note: if the sample sizes are greater than 10, again, if they're larger, an S chart or standard deviation chart is recommended to monitor variation. And it would be made in the same way that an R chart is, right? You just find the standard deviation for sample 1, standard deviation for the next sample, the next sample, the next sample, and then plot those points and look at the chart. But we're only specifically going over range chart today. All right, so some notation to go along with the R charts. When I say, remember lowercase n typically represented a sample size. Now you gotta be careful with when you're looking to make these R charts or X bar charts or any control chart. When I say lowercase n here, it doesn't mean the size of everything that was collected. It's the n here is the size of each sample or subgroup. What's the size of the first sample, the second sample, the third sample, day to day or year to year or month to month or whatever. All right, so it's not everything that was collected, but the size of each sample that was taken at each individual point in time. Right? And you'll see R bar. Remember, usually when there was a bar thrown over something, it meant the mean, right? Like X bar was sample mean, right? R bar is the mean of the sample ranges, right? So you take a look at your list of all the ranges of all the samples you've taken. You add those all up and divide by how many samples there were. That's your R bar. And then on the chart or on the graph itself, remember those 3 lines that I mentioned? The center line, upper control limit, lower control limit. Where those lines will be placed are at these places. The center line, as I mentioned on the first page, is at the mean value of the ranges, right? That we're doing if we're talking about an R chart. The center line will be located at R bar. The upper control limit and lower control limit are going to be found using tables. Right? There are some tables that will be made available, hopefully made available to you, or if not, just do a quick search for them. A table for a control chart, control limits for control charts. The upper control limit, or UCL, will be located at the value D sub 4 times R bar. Alright, so whatever this R bar is showing up here, but it's multiplied by this factor of whatever D4 is. And the lower control limit, LCL, is at D3 times R bar. Alright, and this D4 and D sub 3 that I'm seeing here, these are found in a table for control charts, right? And if you're not provided one, just do a quick search. They're easy to find for the look for a table for control limits for R charts or just control charts. All right. So let me get into my example. I've just got one because again, these can take a while to create, especially if you were trying to do them by hand, which I wouldn't recommend. Usually when you're creating control charts of any kind, you're monitoring a lot of data, right, over a long period of time. So making these by hand, I wouldn't recommend. You can do it; it's not impossible. But I would recommend using some sort of technology, whether it be a calculator or Excel, Google Sheets, Minitab, SPSS, StatCrunch, programming in R, whatever. There's lots of technology out there that'll enable you to make charts like this. All right, so in my example today, and I'm going to also be using this example, this same table of data in my next video on X-bar charts as well. But for R charts, right, so see the table of weights in grams of quarters minted by the U.S. government. All right. So here's how the quarters were taken. All right. So the government, a certain like let's say we're at the Denver Mint. They're minting quarters, creating quarters in some with machines and manufacturing process here. And how they're going to monitor this manufacturing process, this minting process, is a quarter is sampled and weighed each hour, just one quarter, right? Of all the quarters that are coming through the line, to take a quarter out every hour and weigh it, right? Just to see if all the weights are, staying consistent. Right? So it would be a good idea to monitor the variation here, right? Because if the weights are varying too much over time, the spread of the weights of these quarters is getting too large, then that means the machines are out of whack or someone working them is doing the wrong thing, and we need to go in and fix the process, fix the procedure. So a quarter is sampled and weighed each hour for 5 hours. And this is done for 20 consecutive days, right? This occurred for 20 days. And then we monitor the variation, and the question is the variation of the process in which quarters are minted in statistical control? Right. I guess the variation of the weights, right, I should have mentioned, is the variation of the weights during this process in which quarters are minted in statistical control. All right, so let me show you this table that I'm talking about here, this table of weights. All right, so I've got this in my Google Sheets here. And if you have it in Excel or somewhere else, that's fine. Nothing wrong with this. I just downloaded this from somewhere. So you see the columns, and I'll explain the chart. You see the columns here, the days, right? And I said it was done for 20 days, right? So you're seeing days 1 through 20 there. And I mentioned that one quarter was selected every hour for 5 hours each day and weighed. And these weights are in grams. Okay. So day 1, the first hour of the day, they pulled a quarter and weighed it. It was 5.543 grams. And the next hour, they took another quarter from the line and weighed it after it was minted, and it was 5.698 grams. Third hour, 5.605 grams. They pulled another quarter. Fourth hour, they pulled another quarter, 5.653 grams. And then the fifth hour, they pulled a fifth quarter that day, and it was 5.668 grams. So there's one sample, right, for day 1. You can think of this as sample 1. So you're seeing here the sample sizes are 5, right? That's the value of that n. I'm going to go back and write that. Okay, so the value of n is 5, right? And don't think of this is not 100. Right? Remember, this is the size of each day's sample. Right, there are 5 quarters being pulled every single day. Okay, so don't think of this as 100, right? I know a lot of people make the mistake of saying n would be 100 here because there's 5 a day for 20 days. Oh, that's a sample of 100 values. I get where you're coming from. Right? I understand that because, like I said before, most of the time n meant the entire sample size. But here for these charts, we're looking day to day or minute to minute, whatever the times are broken up into, and here times broken up into these days. All right, so this first sample of 5, and then you see my next charts. I've got the x bar written. This is the mean value of just these first 5. I've got the S here, the standard deviation, 0.0607. This is the standard deviation of just this sample of 5 for day 1. And then the range, which is what we're going to focus on in this video. Right? The range of this sample. Right now, notice the largest value here was 5.698. The smallest value 5.543, and if you subtract those, you get 0.155. Right? That's the largest value minus the smallest value in just that first sample from hour 1 to hour 5 on day 1. And I've got this recorded here for every single day for the 20 days, right? So every day for 20 days, they took a quarter every hour for 5 hours. So every sample is five large. Weighed them, and then I've got the mean, right? X bar. I've got the standard deviation, but again, this column I here is the one we're focused on with the ranges. So you see I've got these 20 sample ranges in column I. And over to the side here, and I'm going to do this on my calculator as well, so we can put in the lines for the center line and the upper control limit and lower control limit. But over here I have an R chart. There's an R chart. See where days 1 through 20 are labeled on the horizontal axis, the ranges on the vertical axis, and a little dot where for every single one of those 20 sample ranges, there's the range of each sample for each day. Now, I mean, if I were just looking at this chart, maybe you can see that the variation is getting out of whack. The spread is getting too large. You see how early on, like these first 3 days were all pretty packed together, but then as we move on, these last 3 days, very large variation, much larger spread, especially from day 15 to day 20. My goodness. Right, it looks like the variation is out of control, but we'll say that more finally later. Another thing, definitely that upward shift, right? Look at all these values from days 1 through 15 are within a pretty small band, and then all of a sudden after day 15 there's this major shift upward, and then from 15 to 20 the values are way up here. So I'm seeing this upward shift. I'm seeing a large an increase in variation as time goes on. I'm going to conclude here that the variation in this process is out of control, is not stable. So something's wrong with the machines that are creating these quarters. Something's up with the people who are working them. I don't know, but I do know that I need to go in and fix the problem before it gets too out of hand. Alright, so like I said, I put these in my calculator. Alright, so let me show you. So on my, I got my TA84 Plus Silver Edition up here on the screen. So remember, if you go to hit the Stat button and then Edit, you can enter some lists. And I probably should have entered these in the other order, but see down List 2 here, I've got just the day numbers, just 1 through 20, and then List 1 has those ranges. All right, remember back on the website. Let me go back. Remember this list of ranges. See how it starts with 0.155, then 0.186 for day 2, 0.187 grams of a range for day 3. That's exactly what I have here down list 1. Right, so 0.15, 186, 0.187, 0.122, and I entered all 20 of them. I'll just show you that I do have 20. Okay, there you go. All right, and then day, again, L2 there is just the numbers 1 through 20. All right, the day numbers. And I'm assuming by now that you know how to, because at this point, this is usually one of the later topics in a introductory stats course. I'm assuming you know how to make a scatter plot on a calculator by now, so I'm not going to do that. I'm just going to show you the graph of my scatter plot. All right. Well, it's not really a scatter plot; it's a line chart. Right. But there, and look at this. Right? So these are, each of these blocks here on the graph are the different ranges, right? The 20 ranges connected by a line. And you see how similar this looks to what I had on the website on my Google Sheets, right? So very similar. It's exactly the same actually, right? Just maybe a little stretched out or a little compressed, but it's the same. It's the same exact 20 points, all right? Um, all right. It's the same exact 20 points. All right. So what I want to do now is on the calculator here, put in that center line and the upper control limit and lower control limit. All right. So for the center line, I need to find R bar. All right. Now, in my calculator, as I mentioned, I've already, I showed you, list 1 here is already all those ranges. So for R bar, I'm gonna go to the Y equals menu, because I'm not only going to graph the chart with the ranges in it that you saw. I'm also going to graph 3 lines. So I go to the Y equals menu, and the first one I'm going to graph is Y equals R bar, which is the mean of those ranges. So how do I do that? All right, so I have it in the list already. So I go second, above the stat button you see list, go over to math, and then the mean. I want to enter Y equals the mean of, and that list with the ranges in it, you just got to pay attention to what list you put those in. I put them in list 1, right? So second L1. All right. And then now look at the graph. See, there's the center line. There's the center line. And what is that value? Well, I can figure that out on the main screen. The mean of, the mean. What is the mean of the ranges here? What's the mean of list 1? So R bar is 0.2054. In fact, I will write that here. Right, R bar, that's the R bar, right? It's the 0.2054. Okay. This is the mean of all those 20 sample ranges. All right, let me look at that graph again. Right. Now, just using the center line, we could also see, I mentioned earlier, I'm already going to say that the variation's out of control, right? In this process, the variation is out of control here because of this upward shift at the end and the large variation at the end compared to at the beginning. But also, remember that rule of 8, that run of 8 rule? If I hit the trace button, see how that's below the center line? That's below the center line, below, 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 below. That's 8 in a row. 8 in a row. Now that one's above, but that was 8 in a row. The first 8 ranges, the first 8 days ranges were below this average range, this R bar. We're below the center line, below 0.2054. So even there, I'm seeing another condition where I would say that this process is out of control. It's not stable. The variation in this process is not stable. So lots of things to tell me that this is unstable. All right, but I'm going to go back. And now let's calculate the upper control limit and lower control limit and see where those are. All right, so remember the upper control limit, right, UCL, was that D4 times R bar, right, where D4 is found from a table. So D4 times R bar. And the lower control limit was, D3 times R bar. All right, so let's see what this D4 and D3 are. Now let me show you, I've got a table here back on my websites. This is a table, let me blow this up a bit. A table provided to, a table for control charts. All right, and this is for the particular course that I teach, that's stats. So you see control chart constants. So you see n down the first column, that's the size of subgroup. Remember, n was 5 here, right? Each day the sample size being taken, the number of quarters being weighed was 5. So I go down to the row with 5. And then you're seeing, X bar chart. I'm not doing an X bar chart, right? This was a range chart. And then you see these columns with D3, D4. D3 is used for the lower control limit. So D3 is simply 0. Right, see for n equals 5, 0. So the lower control limit is just 0 times R bar. And I'll have this written on my other page here. Right? So let's see, this is so D3 is simply 0. It's 0.000, it's 0, right? Times the R bar, which is 0. Right? So the x-axis, if you're looking at your graph. Right. Then for D4, for the upper control limit, right, back to this chart. See n equals 5. D4 is 2.114. 2.114 multiplied by R bar, that 0.2054. Right, so back here, let's turn this back on. Now, notice on my calculator, 0.2054 was the previous answer, so let's hit times, and it takes the previous answer, times this D4 I found from that table, that chart, right, 2.114. And we're getting approximately, I'll just go 0.4342. Okay, so all I'm going to do is I'm going to graph all those lines. Now, there's the center line. I hit the y equals again. There's the center line, right? Y equals the mean of the ranges. Then I'm just going to put in the upper control limit, because again, the lower control limit is just y equals 0. All right. So upper control limit was y equals 0.4. I'll just put 0.4342. Now let's look at the graph. You see the lower control limit is just the x-axis. There's y equals 0 right there. There's the center line. That was that 0.2054. And there's the upper control limit coming in here at 0.4342. And even here we're seeing another condition that's broken. See, there's these two values. There are two ranges from the last 2 days, days 19 and 20, that are above the upper control limit. So again, there are like 3 different reasons why I'm seeing that, 4 different reasons why I'm seeing that this process is out of control. It is not statistically stable. So something needs to be fixed. I need to go in and figure out what's going on with these machines that are minting these quarters. All right. So what we're seeing is, and so the question was, is the variation of the process in which quarters are minted in statistical control? Again, back here, look at the graph. So, I'm going to say no for the following reasons. No. The variation of the process the variation of the weights is not in statistical control, is not statistically stable. Right, again, for the following reasons. for the following reasons. One, there's increasing variation, I'm seeing, right, as time goes on, right? All the points started off kind of clustered, and then they got further apart as you went further down, right? That's increasing variation. Two, there are exceptionally high values, right? There are values above that upper control limit, right? In fact, like I said, you're seeing two of those, right, on days 19 and 20. Those ranges are too high. Three, there's that upward shift. There's a noticeable upward shift, right? All the stuff from days 1 through 15 started around the same, and then there was that shift upward at the end, right? Look at this. All these from days 1 through 15 started off around this, within the same band, and then the last 5 days. Let me turn this back on. The last 5 days, man, way up higher. There's a definite upward shift which wouldn't occur naturally, right? So again, out of control. And four, that run of 8 rule. Right here, the center line had 8 consecutive points below it. The first 8, right? The first 8 days were below the center line, and the chances of that happening, right? The chances of 8 consecutive days, 8 consecutive samples being below the center or being above the center is very, very slim. Probably wouldn't occur by chance, wouldn't occur naturally. So again, you didn't have to have all 4 of these, right? Any one of these, right? Any one of these, I'll put ors between them. Any one of these would be enough to say this process is not stable. Right? The variation is not in control, and I need to go back in and I need to figure out how to fix the machines or work with the people who are working, to mint these quarters. Try to figure out what's going on before it gets too out of hand for too many days in a row, and get back to stability. All right. Okay, so there is an example. Again, hopefully you see what to look out for. There's an example of an R chart, how you do calculations for the upper control limit, lower control limit, using tables, and again, what to look out for. Right? Is there an obvious pattern or trend? Is there, that upward shift, downward shift? Is it always increasing, always decreasing? Are there points that are too high or too low? Is there an obvious pattern in the stuff? Are there these runs of 8 all below or all above the center line? Right. Just lots of stuff to keep in mind. Right. And again, how to make it on your calculator. You can make the same chart. Right. Now, I didn't have the control limits and whatnot, but how to make the same chart here, right? You just insert a chart with range versus day, and is what I have in here. And again, no matter really either way, no matter what chart I was looking at, I would have said that the variation wasn't in control, wasn't stable. All right, so I hope this video was informative. You saw how to make a chart, how to interpret a chart involving the ranges of samples over time. All right, so in the next video, I'm going to start going into I'm going to have a chart, but involving the X bars, involving the means, and seeing if the means of these samples are stable or not. All right, so hopefully, and you'll see how very, very similar interpreting an X bar. I mean, interpreting any control chart is the same. You're looking for you're looking to see if the chart violates the same criteria. The only difference is, the data points mean something else, right? In the next video, the data points will be means of the samples instead of ranges of the samples. Or they could be standard deviations of the samples, or they could be proportions of the samples, as we'll get into in a later video on what proportion of the sample has this attribute or that attribute. All right, so hope this was a good introduction to R charts, and I've given you enough now where you could do this on your own, and you could interpret your own R charts, and hey, maybe you might even come across examples where variation is stable. Just again, look out for those criteria. And thank you very much for watching.